Homework 7, Combinations of Functions, Video 9. As mentioned earlier, there were 5 ways that we're going to look at to combine two functions: addition, subtraction, multiplication, division, and composition. Composition needs a little bit of explaining. The definition of composition is actually here. I'm going to put a blue box around it. The symbol for composition is an open circle. Looks like the letter O. The way you write function composition is f of g. When you see the circle, you read it as the word of. So f of g of x. Now, what is that defined to be? Well, it's f of g of x. In fact, if you know how to read the notation, you're saying the definition. F of g of x is equal to f of g of x. Pause for dramatic purposes. F of g of x equals f of g of x. Basically, you're putting one function inside of another. Excuse me. Just a quick comment about the domain. When you're looking for the domain of a composite function, there are 2 places you have to look. The first place you have to look is on the inside function, because whatever your x is, it has to get past that function first. But it also has to get past the final result. So your domain has to satisfy the original first function and the final function. The first function, and when I say first function, I mean the first function the x goes into, the one it's closest to, and the final function. Let's take a look at this example, which should not have any domain issues because they're all polynomials. If f of x equals 3x plus 1 and g of x equals x squared plus 2x, let's find f of g of x, so we're going to make a new function. G of f of x, the order does matter, we'll make a different function there. F of g of 2, now we're putting a number into the function. G of f of 2, now we're putting another number into the function, or the number into another function. To find function composition is actually pretty straightforward. But I'm going to document a how-to list here. How to find f of g of x. Number 1, rewrite as f of g of x. In other words, literally write what the definition is saying to write. So let's go ahead and do that on this first one. F of g of x. Now, we have parentheses, and that usually means go inside and do that first. So we're going to go inside these parentheses and quote unquote do g of x next. Now, how do we do the function without a number to put into it? The answer is we don't, but we can replace it with what it equals. Replace the inner function with what it equals. So we're going to go into this expression f of g of x, and we're going to replace the g of x with what it equals. The f of x we're not doing the f we're not doing anything with, so it's just sitting there for a moment, waiting for the inside function to change. In this example, g of x is equal to x squared plus 2x. So we're going to replace the g of x with x squared plus 2x. And this turns into a type of problem that we've seen before, where we're taking a function of an expression. So how do you pull that off? Well, let me do it, and then I'll write the step that correlates to it. The easiest way, in my opinion, to find the function evaluated at an expression is to copy the function, which in this case is f, but replace the x with parentheses. So I'm going to rewrite 3x plus 1, that's what f is, but I'm going to replace the x with parentheses. Space this out a little bit. And guess what's going to go inside those parentheses? The x squared plus 2x. So how can I write all this? Let's see. Step 3. Write the outer function with parentheses instead of x's, and then fill in the parentheses with the inner function. I'll be honest, we could get right to these last 2 steps immediately. Your 5th move is to simplify. So let's see what happens if we simplify this. Well, there's not a whole lot to simplify here. We can distribute the 3 and get 3x squared plus 6x, but don't forget the plus 1. And that's it. We don't have any like terms to combine. I made a new function by putting one function inside of another. What's the domain of this function? Well, we have to check it with the domain of the first function and the final function. Both of these are polynomials, so the domain is just all real numbers. But what about the second part, g of f of x? The same thing, just reverse the order of the functions. But let's see if we can do this a little bit more efficiently. Yes, you can do the first step. Yes, you can do the second step. But think about the third and the fourth steps. The third step says write the outer function with parentheses instead of x's. I can do that right now. I can write the g of x with parentheses instead of x's. So let's write what g of x is, but use parentheses instead of x's. G of x says x squared, so I'm going to put parentheses squared, plus 2x, so I'm going to put 2 times parentheses. I'm doing the g function, but I'm doing it to the f function. Fill the parentheses with the inner function. I'm going to fill these parentheses with what f of x equals, and f of x is equal to 3x plus 1. The hardest part about these is the setup. But the outer function will dictate the structure of what you set up. Replace the x's with parentheses. And the inner function is what is going to go inside of those parentheses. Now, as far as simplifying this, be careful. This is a FOIL problem. It may not look like it because you don't see 2 parentheses, but the square implies that it's a FOIL problem. I'll bring these 2 back in just a moment. If we were to FOIL this, we would write 3x plus 1 times itself. And why don't we go ahead and distribute over here because we can. 6x plus 2. If we FOIL this, we would get 9x squared plus 6x plus 1. And then we still have the 6x plus 2 at the end. And then the like terms, we have 2 pairs of like terms. There's only the one x squared term, 9x squared, but plus 6 and plus 6, plus 6x and plus 6x is plus 12x, and then plus 1 and plus 2 is plus 3. And the domain of this one would also be all real numbers because the first function, the 3x plus 1, and the final function, 9x squared plus 12x plus 3, are both just polynomials. So function composition can get a little bit congested because you're putting one function inside of another, and the simplification can be pretty straightforward if you just stay focused. The parts that I erased were to find f of g of 2. You could find this by doing the actual function problem. I'm going to erase the red list. If you need it, just back the video up. But if you're doing a composition evaluated at a number, there's actually 2 ways to do it. Number 1 is to actually do what the problem states. So f of g of 2 is f of g of 2. But unlike part A, I can actually do this. I can actually figure out g of 2. So let's just talk it out real quick. If I take the 2 and put it into the g function, if I put 2 here, 2 squared is 4. If I put 2 here, 2 times 2 is 4. 4 plus 4 is 8. G of 2 is 8. And now I can just stick that into the f function. 8 goes here. 3 times 8 is 24. 24 plus 1 is 25. So that's one way to do f of g of 2. Or, because we already figured out f of g of x, we could take advantage of this answer. F of g of x is equal to 3x squared plus 6x plus 1. Well, to find f of g of 2, I could just substitute the 2 for the x. 3 times 2 squared plus 6 times 2 plus 1. 2 squared is 4. 4 times 3 is 12. 6 times 2 is 12. And we have a plus 1. 12 plus 12 plus 1 is 25. Same answer, but then again it should have been. And for part D, I'm really using the space here. For part D, g of f of 2, we have two options. Send it into the f, take that answer, send it into the g, or substitute the 2 down here. Let's see if we can do it verbally both ways. Let's try the g of f of 2 approach. We need to stick 2 into the f function. If I put 2 here, I'll get 3 times 2 plus 1. That's just 7. Now I have to g the 7. If I put the 7 into the g function, 7 squared is 49. 2 times 7 is 14. 49 plus 14 is 63. Or, we could put 2 here. Let's just talk it out to make sure we get 63. 2 squared is 4. 4 times 39, what? 4 times 9 is 36. Plus, we're putting 2 here. 12 times 2 is 24. Plus 3. 36 plus 24 is 60. Plus 3 is 63. So, on the surface, function composition is actually pretty straightforward. It just gets a little tricky because you're putting one function inside of another.